Hi everybody, today we are looking at data-driven game assets, how to find sources, how to insert them into Unreal, how to generate textures for it, and how to use them then in the game. Target is something like this here with my starting inventory. I have a lot of materials, raw materials, that's actually the periodic element system, and these elements can be used for whatever, for crafting, for whatever. So we have a very huge base of things to do something with it later. We also want to think about how to generate things like textures automatically. That would be Stable Diffusion in our case. So we will do a short installation of Stable Diffusion and think about how to do that also data-driven. We're thinking about how to consume the data using cached data registry, using data tables, and how to update that accordingly. Then we will think about what could be possible sources. In our in this scenario, we will just use the periodic table of elements as one source of raw data. You know, in RPGs, you normally have iron and copper and gold and stuff like that. In our case, we use 100 of the periodic system elements. Then we have information like, for example, the abundance of elements. So how often does something exist in the crust of the earth? That would give us nicely a hint how often it should be used in the game or should be findable in the game. So we are using tables for that. The result should be that we have an element description, that we have maybe a couple of physical values like melting or boiling points, that we have a description of it because we want to use that description to generate later our textures. Then we want to have a stable mechanism to generate the textures, in our case Stable Diffusion XL. Result should be that we have many textures for all the elements, and each texture should be in different resolutions, or also that should be automated. Then we want to import the whole thing, import the textures, import our data-driven tables, and start working with it. So in our case, I start here at this URL. That's one of the examples for the periodic table of elements. Good thing is you need elements. If you have something like an RPG, you need iron, you need gold, you need something else. But here in our case, why not use what is there? So I took around 100 of the elements and use them to insert them into the game. And at the end of the day, you can build everything out of it because we are built out of these, like carbon, for example. Yeah, we're existing of that. So, and it comes with a lot of nice information. It comes with a description, how it looks like. It comes with things like boiling and melting points. It can be used for special things. For example, run gaming is not often there and it's not stable, so it's a dangerous element. That could be a game mechanism. So if you have your source, you have to somehow load in something to work with it. In my case, I use Google Sheets. And then you enrich it what you need. For example, you need a GUID. The GUID should be something unique, identifiable in the game. Important here is that it should be stable, because if I do a re-import, then it should not change. So what you have to do, you generate it here, and then you copy paste it just as values to be sure that this is text now. It's not a generated thing, this is text. And then you replace your GUID column with the text-based ones to make sure that they are not refreshing with every update of the table. Now these are stable and can be used throughout the game. Then the rest of the things here are coming directly from the source, but the texture path is something new. Texture path should be something where I can dynamically assign a texture to an element in the moment of usage in the game, so via a soft reference. What I did here, I copied a texture path from the game and will update it accordingly. The $signs will be the texture resolution, and the paragraphs will be the texture name. That is done here in the GSheet. If you go to one of the textures, you see I have different resolutions here, and just right click here and look at the copy reference, and that will be exactly how Unreal references that asset. That is something that you can use for your soft referencing, for example. Looking at this, you would have to replace, as I said, the $signs with the resolution that you want, and here in the sheet we will replace the paragraphs with the short name, and then we can really dynamically build texture path in Unreal to access it. Something like this here. So in Unreal we just would replace it with a resolution. That would depend on the scenario where you want to show the whole thing. And then we will load it dynamically. Then we have two more columns enriched, and these are color columns. So this is a color value. All this easy thing is to put something into Unreal, export it in CSV, then you see how Unreal is expecting that. The color value could be, for example, used in dynamic materials. We have a description how these things should look like. So here I have an element that is a bit of violet. If you see it here, it's a bit hard to see, but the rocks are kind of emitting a violet color. And that is the material doing that. It's a standard material with a couple of textures, but we added here an emission color or two emission colors with a noise generator. So these two colors are parameters that I can set dynamically when creating this rock. So the idea is that I, for example, if I have a rock containing silver, I would go to my table, see, yeah, silver is kind of silver, white, and then I would dynamically set these two colors to the right one, so that regardless how many of the elements I want to bring in the game, I kind of automate how they should look like and just assign the material to whatever asset I deem worthy to contain silver. And then even from the outside, somebody could actually say, okay, that might be a silver node. Then this based harvest volume, the question, how much do I harvest per unit? Yeah, in my case, I just say, okay, depends on the if it's a gas or solid, and then automatically is set to a special thing. Then the abundance, so the question, how often does it exist? How often should it be dropped in the game? Again, I do it data driven. So I looked at a table where the abundance in the earth crust is actually pointed down. So for each element here, I have the information how often it exists in the earth. And here I could say, okay, if it's quite often there, it should also be often in the game. So it's a common thing. Or it can be uncommon or rare or epic or artifact for things that are extremely, extremely hard to find in the earth crust. And that automatically would do things like, for example, aluminium, that is quite often there, and silver or gold is kind of rare. And these things are, again, automatically there, and you can really put the drop chance that it's generated automatically in your game could depend on that. These are just examples what you could do with data-driven design and then put it into game mechanics. The important next step is that you create a structure that is exactly like the column structure with the exact same name as you have in your CSV. It can contain more columns, that's not a problem. They will be ignored, but they have to match one-to-one in the description, and the format, of course, that you import needs to be the same. Best thing is you create it, you add one data set manually, then you export it and have a look at the CSV that is generated like that. And then you know exactly how Unreal is expecting GeoIDs or expecting colors and stuff like that. And then you know how to import it from your CSV. And if you have that, you really just can re-import it again and again and again, and you will get an update in Unreal. How do I get it there? Yeah, simply I go to my table. I'm sure that all the column names are fitting. I export it as CSV, comma separated value. And with that CSV opening, that is exactly the text information that I then can just pass over to my Unreal exported file and can re-import it. So I take it here, I kind of copy it. I then go to the file that is exported directly from Unreal and can replace all the information with the new one, save it and re-import. So here I delete what is there. I passed in what I have generated new. Here's one caveat. Sometimes, depending on the information, you will get 3 of these apostrophes. You have to convert them to 1. So Control H, and here for Node++, and the 3 apostrophes to 1. And then it's really ready to be used. Here you just save it, go to your Unreal and the data table, for example, or the data registry, re-import it, and there on the lower left you see, yeah, imported, no problem, successfully. And that is the way really to update it with new information, new lines that you need, even new columns, and then just make sure that the structure is fitting. Next thing is how to generate the pictures. Again, automatically, we want to do that data-driven with stable diffusion. I generated a prompt where I will replace certain things, and the prompt in this regard is trying to generate a flask of a potion, and that I will then enrich with the information that I get from the CSV table. So you hear it's a white background, in the middle is a laboratory flask filled with something, and this something should then be an element like helium or whatever. It looks like blah blah, so it looks like the description that I got from the CSV file, and putting that together and substituting the information that with the information that I got from the original source, I can generate a text file that is just a prompt. Each line is one prompt for Stable Diffusion to generate things. So that brings us to Stable Diffusion. I use Stable Diffusion XL to make sure that we can ingest that information. So just go here to the URL. I use ComfyUI as a UI to Stable Diffusion because it's, for me, for data-driven things, the easiest to work with. You just download it. You have to download the models. There are some introductional videos how to do that, and also here the website is doing a good job explaining. You need an NVIDIA graphic card for it. Don't try it on a CPU. That will not work. It's much too slow. So downloading the models that you need here, you should have it running really within a couple of minutes if you download it fast enough. Then you can just start it and get your local web interface with ComfyUI. ComfyUI has a big advantage. It's node driven, so meaning you can really see what's going on. You can manipulate it quite easily, and you can drop existing pictures just into your browser interface, and it will regenerate the node network that was used when this picture was created. So that also makes it very nice to learn things. That is the ComfyUI web interface. You also need a node network. I use here the Searge-SDXL. That's one example. You can use others. It's not really fancy what I do. I really rely on the prompt information without much more. So no control net or something that would be actually usable or nice to generate text much more easily than I did. But yeah, I kind of did a bit brute force approach. What you should see here when you have the manager, that's very important to install. One thing is missing here because the standard network does not support this text-driven information. What you need is the WAS node suite, this one here. So that is the one that you have to install using the manager. So be sure that this is there because it gives you certain text processing nodes that can be used for batch processing, what we want to do. Looking here at the standard of Search, normally you have your main prompt and your secondary prompt. That is quite cool for single pictures, but yeah, not enough for us. So let's unfreeze it here. Yeah, now you can move it around. Let me delete this preview. And here you see that the main prompt goes here to the prompts to the main prompt. And we want to replace that because we want to make it data driven. We want to use our text file that we generated. So these two nodes we need. Double click, and the first node is called load text file. That is really the pointer to the file. The next one is text load line from file. So line by line, a prompt will be loaded. And if you connect these here, so with the multi-line text, and that one with your main prompt. Yep. So then the further single prompt is actually not there anymore, but now we use the new one like this. So and that gives the ComfyUI interface the approach to load a new line per prompt and generate that line. And that can be thousands of lines. That will take, of course, many, many hours. You just point it to your prompt file that you generated somewhere on the disk, and then you give it enough prompts, and the prompts will start going through it. You have to then control your pictures. A lot of them will be crap, but everything that is right, you just remove from your configuration file, from this prompt file, and concentrate on the rest ones. And after many hours, you will have enough pictures to work with. So that should be the result. In our case here, 100 pictures, I think 99 pictures actually, with the symbol on it, with a name, with different resolutions that I need to create. And the question is how to do that. I started with 2K resolution because that is what ComfyUI generated. And I use ImageMagick that you can download here, install it and have it in your path so that you can start doing batch file processing. just open a command line prompt here. And now I want to tell ImageMagick, please go into this directory, take all the files that you find and resize them to 50%, so from 2K into 1K. So for percentage I as our variable, in all the PNGs that you find, do something, please use the magic command, do consume the parameter, do a resize to 50%. And last thing is the file name. The new file name should be, let's say 1K underscore the original name, something like that. So go into the directory, resize everything to 50% and be done. And then of course I would take the resulting textures, the new ones, and copy them into a special folder to be then imported to Unreal at one point of time. Okay, let's do that. Running through it. And every one of these pictures is now converted from 2K texture to 1K texture. And in the game, depending on the situation, how big I want to show it, I can react accordingly. This utility is also quite cool. Bulk rename utility, you need it quite often really for this kind of work. If you don't want to do too much command line prompting, really just very, very easy, replace one string with another string for many different files. So let's sum it up. What did we do? We imported a data source, can be whatever. I used the periodic system, but it can be everything you can think about. It needs to be accessible, it needs to be a database, it needs to be a CSV so that we can manipulate it accordingly, because at the end we need again CSV data information. So finding that information, elements is one. I saw great plant databases and so on and so on. That is the first step. Then we need a structure to manipulate it. I use Google Sheet quite often because it's free and very powerful. So we have to align really the Google information that I have, the sheet information, with our struct in the game. Then we can import this CSV information into either a data table or a data registry. And then make sure that we have an easy update mechanism, updating it with new information if we want. And next step is to think about text generation. Should be once at a time what you have to do it at the beginning. So you think about, let's export the prompts, let's import into Stable Diffusion and do a batch run, for example with ComfyUI, to generate these textures. And after a lot of examples, you will have very, very nice looking textures that you can use. Then recreate these textures in different resolutions, because you want to make sure that you are not loading very big ones like 2K for just mini tiny inventory items. So that's also something that you have to think about. So that's an end-to-end process here as an example, how I try to push certain things into inventory. That's the background. I'm still working on the inventory here. And with a bit of luck, we have a working inventory with these nice textures and with a lot of information that I can do for game design in the background. And